You can start teaching now.
Can I start teaching?
Yeah.
Okay, this is mostly a review of something that took me a long time to explain last time, so I'm just going to summarize it really quickly. If the lines cross and have one point in common.
Intersection. Oh, he said it.
Sebastian said it. He's the only person that's talking.
What would you call those lines?
Intersecting lines.
Parallel.
Yes, they're intersecting lines, but they would be dependent, independent, or no, consistent, inconsistent. Do you remember?
Inconsistent.
No, you don't remember? I explained this.
I forgot. Maybe you didn't agree.
That's right.
No, I remember.
Yeah, she did.
Maybe you told us
I
last
did.
year. But
No. This year in this class, because I remember using both boards.
It's
Remember when you have a system? Yeah, I did teach it. When you have a system, for example, 3x plus 2y equals 4, and 2x minus y equals 6. There's nothing in common with these. These are going to be two lines that intersect at a common point, and they are called consistent, aren't they?
yeah. Because they have a solution. Like you can have a solution.
Yeah, these are called consistent lines. Look in your notes. I'm sure I have it. I talked before.
Look in the YouTube videos.
Yeah.
no.
No?
No, this
Maybe not. Maybe it was 8th grade.
Yeah, I think so.
But I'm pretty sure I did.
My notes are.
You taught us on 9th grade, but right before we started recording.
I don't think
It needs some other English.
No, you don't have it? Okay, so let's review it then. Let's review.
Do I turn?
Fine.
Do I turn?
You haven't turned it on yet?
No, do I turn?
Oh yeah, turn.
Hey, Sami. Move.
There we go. Wait.
So this is what you're used to, right? This is what you're used to, and you know that you're finding that point in common, which is x, y. So that's why when you solve for x and y, you are finding that point that they have in common. And because it is in common, is that you can substitute this x, and this y, and this y, even though they are two different lines, okay? Because they do have that intersection, that point in common. Is that part clear? So those lines are called consistent lines, okay? What happens though if you take two lines and you tell me what's going to happen right now?
Awesome.
Let's say that they give you this. This is the second case. They give you two lines and they look like this.
So hot.
Because Sebastian is here. What? I don't know.
You just complimented him.
Okay, what happens when you look at this? What do you see? Is there something?
I see numbers.
You see numbers. Good for you. So now, if I leave the y by itself on this one, y will equal minus 3 divided by 1, right?
What?
X
Well,
plus 4, right?
yeah.
That's what you have, correct?
Yeah.
If I leave the y by itself here, because I know that this is, I will have minus 6
No.
x over
Plus 8.
2 plus 8 over 2. Is that correct?
Yeah.
So I'm going to simplify this,
Yeah.
and I have,
Negative
let's
3x.
make it different so that this is 7.
But that one stays the same.
This would be minus 3, and this would be
4.
8. 4, yes.
Yeah.
What do you notice?
They look a little like
They have the same slope,
Yeah.
right?
103.
Same slope. And what do we know about lines that have the same slope? They are what type of lines?
Parallel.
They are parallel lines.
And parallel
Parallel.
lines are consistent.
Parallel lines are inconsistent.
Inconsistent. That's what I said.
Yes, sir.
Yeah.
Okay? So, parallel lines are, as you very well said, inconsistent.
Oh yeah, I thought you said consistent.
Inconsistent. and therefore have no points in common because they never touch. Okay? They have no points in common. And then we have the third possibility, which is let's say 3x plus 2 equals 4, which is why, so 2y equals 4. 6x plus 4y equals 8.
we always leave y by itself.
Do you need this?
Because
What do
y
you
makes
notice
y
when you look at this? At these two lines? Is there any pattern, anything that
Y-
grabs your eye?
The first one is the second one.
Oh,
is
the,
2 times
the one
two.
on top is
This one is the first one times 2,
the third time.
right? Or if you want to look at it another way, this one divided by 2 gives you the first one, right? Either way, these two are intimately related.
Yeah.
Why? Because they're exactly the same line.
Multiply times minus 2.
If you can multiply one of the lines times a number and you get the second line, it means it's the same line, okay? And if it's the same line, if I graph it, one's going to be on top of the other, isn't it? Or it's the same line. Is there an intersection if that happens?
Yes.
All the time.
Every single point, right? Because it falls one on top of the other, because it's the same line. If it falls one on top of the other, how many points of intersection do you have? You have infinity. So you have no single solution. Would you agree?
Yeah.
These lines, where the equations are the same thing, it's the same line, are called dependent lines. Why do you think they're called dependent lines? Because one depends on the other, right? You multiply this one by a number, you get this one. Or you divide this one by a number, you get this one. They depend on each other. They're the same line, okay? That's why they're called dependent. Is that clear? So, when you go and you look at practice, and I'm going to do the practice in a little corner over there. So, is it clear that you have 3 types of relationships between lines? They're either parallel lines, dependent lines, or consistent lines. Okay? Let's see. Let's look at an example. They're going to give you this. Example. 3x minus y equals minus 2, and 2y equals 6x plus 5. What do I suggest you do? And they're going to ask you, is this system of equations consistent, inconsistent, or dependent? What would you do?
Leave y alone.
Leave y by itself. That's the easiest way to see, right? So let's see. This one gives you that y equals minus 3x plus 2. Very good. And this one? Y equals
3x
3x
plus 5.
5 over 2, right? So, do they have the same slope?
No.
No.
No, they don't. They have a 3, but this one's negative and this one's positive.
Yeah.
No same slope. So if they don't have the same slope, they're not parallel, they're not inconsistent. Can you get this one out of the... Is this one a multiple of this one or vice versa?
No.
No, right? You can't multiply anything times this to get this. So they're not dependent.
Y equals 3x
Then what
plus
do you
2.
do? What do you do?
No. Because you've got a minus here. So it changes it. Huh?
Then what?
Can you multiply this by a number, let's say 2,
No.
and get the bottom one?
No.
Can you divide the bottom one and get the top one? No.
So
So if that's
It's
not,
consistent.
Miss,
so they're not
It's not.
dependent.
miss,
So they must be,
Consistent.
Consistent.
wait, miss.
and that's all you have to say, consistent.
Okay.
Miss, aren't you passing the 3x to the other
I
side?
can literally
Is
get.
this like the answer?
Yeah, this
In the
it
bottom.
is.
Yeah, you get a positive
I
3x.
told you.
Yeah, but
Sir.
it's,
Yeah?
it's there.
In the top one.
But then it's inconsistent.
Look, minus y equals
Negative
minus 3 either, right?
Ay,
See,
miss.
miss, I was telling you.
Minus 2.
This is positive. Ah,
I told you.
good. I'm glad this is being caught on
Wait,
tape.
what?
Good.
That
So,
was clever. What
because
We did it.
I did it wrong,
I saw
and it
it.
was correct, it is 3x plus 2. What happens?
So then it's dependent.
Oh.
They have the same slope.
Dependent.
Dependent.
Same slope means they are what?
Inconsistent.
They are parallel if they have the same slope. Therefore,
They're
they are
Dependent.
inconsistent.
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 Is there?
Mistake. Don't copy.
I was looking at it.
Okay? Is it clear?
Yeah.
Do you want another one?
No.
No?
No.
Okay.
We're just leaving the.
Yeah.